Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room. The Orbit 2 team is on console this morning, working with the Expedition 55 crew members during the last few hours of their work week on orbit, also keeping an eye on station systems and coordinating the activities of the other station control centers scattered around the world. Since there were no arrivals or departures of spaceships this week and no spacewalks conducted by the crew, science work in the station's laboratories has been a top priority for the astronauts and cosmonauts, along with a variety of maintenance tasks that are necessary to keep the station operating in good shape to support that science.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Catherine McLaurin. In addition to continuing research, the crew welcomed some new equipment to station this week. The crew inserted the ACE T9 module inside of the Light Microscopy Module Auxiliary Fluids container. The ACE T9 experiment involves the imaging, folding, and assembly of complex colloidal molecules within a fluid medium. These so-called colloidal molecules are vital to the design of new and more stable product mixtures. Since November 2000, when humans began continuously living in space, the team at NASA Johnson Space Center Mission Control Center have watched over every crew, task, and system on station. A new NASA ebook offers an inside look at the time and energy the flight control teams in Houston devote to development, planning, and integration of a mission. The International Space Station, operating an outpost in the New Frontier, not only explains the functional elements of the space station, but also provides a day-in-the-life viewpoint to illustrate how flight controllers operate at different points of a mission. The book was written by 10 ISS flight directors with over 45,000 hours of combined experience at the helm of mission control. The book is available as a free download at nasa.gov/ebooks. This week's question comes from Smriti. He wants to know what's the process used to convert urine into reusable water on the space station. Unlike the earlier days of human spaceflight, when all water was delivered to the crew as expensive and heavy cargo, we are now able to process urine, crew sweat and respiration, and convert it to water. The water recovery system collects urine and pumps it to a distiller, which then spins to create an artificial gravity field. The urine is pulled to its walls, then heated to evaporate the water from the waste. The steam is then pumped to a tank, joining water recovered from crew sweat and respiration. Odorous gas is removed, and then it's pumped through several filters before iodine is added for microbial control. Keep sending in questions using the hashtag #SpaceToGround, and we'll see you next week.
As part of the International Space Station's science goal to learn more about human physiology during long-duration spaceflight, NASA studied the cardiovascular systems of identical twins, astronaut Scott Kelly on the station and his brother Mark on the ground during Scott Kelly's one-year mission. The results from the CardioOx investigation may provide a better understanding of cardiovascular disease risk that astronauts encounter during and after long-duration spaceflight.
We're doing something that no one else has done before. So this is really a first foray for NASA of getting into the genetics, the genome part of science. The whole twins experience is really exciting for us overall. When the one-year mission came about and Scott Kelly was assigned, there was a recognition that, well, Scott had a twin. So why not take the opportunity to study one person in space and then one person on the ground? In our experiment, CardioOx, we're looking specifically at things that might modify or might have an effect on cardiovascular disease. So the more that we learn about cardiovascular disease risk, the more it benefits the everyday person. So the focus of our laboratory is to understand, obviously, the implications of spaceflight weightlessness on the cardiovascular system, as well as changes in the crew members' diet, their activity levels, their stress levels, their sleep patterns. These sorts of physiologic changes are ones that we would expect for people who are on for a 6-month transit mission to Mars. So we want to understand what are the potential health consequences, and more importantly, what are the sorts of things that we need to do to prevent them. The tough thing about doing spaceflight research is that, for example, our biological samples, in our case, the blood and urine samples for which we're deriving a lot of our science, they stay on station for a long period of time, and we have to wait for the next opportunity for them to come down. So you have these long gaps in getting actual space flight data, but in the meantime, you have other research studies that you're working on. So we always stay busy. We always try and keep asking new questions, things that we think will benefit both our crew members as well as the general public.
Because a relatively small number of human beings have been to space so far, scientists who are studying how people respond to being in that environment need some help with their research. Help like the use of model organisms. That is, living organisms that have a genetic makeup that's relatively well documented and understood and is similar to human systems, but organisms that can be studied in larger numbers. Organisms like fruit flies. Now, research on technology is another aspect of the International Space Station's science mission. In fact, you're looking at a live view of flight engineer Ricky Arnold on board right now, replacing a furnace in the materials science laboratory. There was a recent delivery of another experiment called optical fiber production in microgravity, which was provided by the private company Made in Space. That operated on the station for a few weeks and then was returned to Earth on the same Dragon cargo ship that brought it to orbit. Its goal was to demonstrate both the scientific and commercial merits of manufacturing exotic optical fibers in space.
We're excited at Made in Space to work with NASA and CASIS to use the ISS National Lab. Made in Space fiber optics is a payload to manufacture Z-band glass fiber in microgravity. It will produce hundreds of meters of very, very high-end optical fiber. Manufacturing fiber in microgravity has been theorized to increase the performance by creating a better product. And by better product, I mean a clearer, more pure glass. And that is due to the microcrystal formation. It makes the glass a little cloudier when the crystals form here on Earth. And in space, it'll be more pure and clear. And in microgravity, they form in a different way, in a more pure way with fewer defects. What could happen is a 100-time increase in performance. This is a really cool project because it can benefit everyone here on Earth. You know, fiber optics are used for various applications, medical devices, lasers, but also internet. And this can really help, improve bandwidth and performance and lower the cost of internet and data centers. So really, it's a product that can affect everyone.
Technology research is just one part of the science mission on the International Space Station. There are experiments underway in many disciplines, such as human physiology, plant biology, space physics, and more. Now, one thing that all of these experiments have in common is that they're taking advantage of a condition on the station that can't be replicated on Earth: microgravity.
an out-of-this-world research lab. Presented by Science at NASA. Every now and then when the sun sets, a bright light appears on the western horizon. Gliding silently overhead, it is the biggest spacecraft ever built by humankind, the International Space Station, or ISS, carrying a precious cargo of astronauts around Earth. But the ISS is more than just a bright light in the night sky. It is also an out-of-this-world research laboratory. The interior of the ISS is furnished with laboratory equipment and chambers for experimental research. It's not as large as some Earth labs, but it has one thing that Earth labs do not: microgravity. Gravity influences everything that happens on Earth. It's hard to envision what life would be like without this force, yet removing the pull of gravity can be uniquely instructive. Reduced gravity provided by the ISS is a major attraction for researchers, says Joseph Nugget of NASA's Johnson Space Center in Houston, Texas. The weightless environment allows scientists to gain insight into basic phenomena in many fields. For example, says Nugget, we all have seen that roots of plants grow down into the Earth. Is this because of gravity? Experiments with plants on the ISS can tell us. Understanding how roots grow is directly applicable to space exploration. What does NASA need to consider when designing a plant chamber for food or life support in space? Farmers on Earth are interested too. A deep understanding of roots can help scientists design hydroponic chambers for agriculture in areas with poor soil conditions. Since the first modules of the ISS were launched in 1998, up until 2017, more than 2,400 investigations have been undertaken by over 3,400 researchers in over 100 countries. Astronauts have spent more than 36,000 hours helping run the experiments for scientists back on Earth. To date, more than 1,600 scientific journal and magazine articles have been published reporting the results. It's a scientific bonanza. There are 5 major research areas on the ISS: biological sciences, such as the root experiments; physical sciences; space science and fundamental physics; human research; and earth science. Nugget has favored examples of each. Scientists grow crystals on the station to discover new crystalline forms. Protein crystals grown in small chambers on the station reveal information that helps find new, novel ways to combat disease. The space station is also equipped with furnaces that can melt solid metals and alloys. This can reveal the metal's crystalline structure in a new way and give greater insight into the properties of the material. While protein crystals are a biological science and metal solidification is a physical science, both are examples of how crystalline structure develops in microgravity differently than on Earth. Switching over to fundamental physics, he says, there are several investigations on the ISS that examine fundamental laws of physics and continue the search for theoretical particles. The alpha magnetic spectrometer, for instance, provides valuable data on the existence of dark matter. Human research is also very interesting and dynamic, helping NASA get astronauts ready for deep space exploration with many spin-off benefits for people on Earth. Nugget notes, research like the lighting effects study helps improve our flight team's productivity on the ISS and on the ground here in Mission Control, as well as the many American workers who work on night shift or alternating shifts. One-year missions to the ISS return much information about how the human body adapts to space travel, from the genetic level to how the astronaut deals with the long-term isolation within the spacecraft. Not all research conducted on ISS requires reduced gravity, he notes. For example, the ISS is a great place to observe the Earth. The station passes over the vast majority of the Earth's populated areas. Sensors and cameras on the ISS can contribute to disaster assistance, tracking hurricanes, measuring wind and rainfall, as well as documenting events such as volcanic activity. The ISS, much more than just a bright light in the night, indeed. For more from the International Space Station, visit www.nasa.gov/station. For more news about science on and around the Earth, stay tuned to science.nasa.gov.
The International Space Station crew spent some time this week talking with three separate groups of students on the ground. That's a more common thing for station crews to do during this year of education on station. Astronaut and former teacher Joe Acaba was on orbit for expeditions 53 and 54, and now astronaut and former teacher Ricky Arnold has taken over for expeditions 55 and 56. NASA has activities planned for this year with a teacher on board to help students and their teachers on Earth get the most out of learning about science, technology, engineering, and math. And that includes a series of STEMonstration videos. In this one, Joe Acaba talks about exercise on orbit.
Hey there, my name is Joe Acaba, and I'm living and working on the International Space Station as part of Expedition 53. One of the best parts about living on the space station is being able to float. Just like you walk from place to place throughout your day, we float from place to place throughout our day. However, we have learned that the same thing that allows us to float, microgravity, is hard on our bodies over time. Our muscles and bones are made of millions of tiny units called cells, and these cells can have problems in microgravity. Up here on the station, bones and muscles no longer have to support the weight of our bodies, so they get weaker. Astronauts could develop something called muscle atrophy, where our muscles become weak from lack of use. Each bone in your body is made of cells too. A healthy bone has more density than an unhealthy bone. Weakened bones can lead to a disease called osteoporosis. Fortunately, our scientists at NASA have figured out one way to keep astronauts healthy and strong. It's called exercise. Let's take a look at how astronauts exercise in space. This machine here is the Advanced Resistive Exercise Device, or we call it ARED. It simulates free weight exercises in normal gravity to work all the major muscle groups. ARED's primary goal is to maintain our muscle strength and mass so that we have less of a recovery period when we land back on Earth. All right, so there's looking at lifting. But what about a little cardio? We have a treadmill for that. Let's check it out. Staying physically active helps both astronauts in space and humans on the ground to stay healthy. And it prevents muscle atrophy and osteoporosis. Now you can try the activity connected to this video to learn more about muscle and bone cells. I'm Joe Acaba, and I hope you enjoyed learning about exercise on the International Space Station. We'll see you next time.
As we have mentioned a time or two, the International Space Station is not only a home for science, but it's a tool for getting humans ready for their next step out into the cosmos. That future trip will be on board the Orion spacecraft, which is being developed here in Houston. The latest in a series of tests to evaluate how well astronauts and ground crew can get out of Orion in an emergency on the launch pad was completed recently at the Johnson Space Center's Space Vehicle Mock-up facility. Data gathered in a series of test runs will help engineers evaluate the design of the capsule and refine the procedures to make sure that everyone will be evacuated as quickly as possible in cases where the launch abort system is not required to be activated, such as a crew illness or the presence of fire or toxins in the crew cabin.
We have to have the procedures to do that, and the vehicle has to be built in such a way that they can quickly get disconnected from the vehicle. This testing is really to go set all of those situations up and see if we're designed to the point that we can get the crew out within 2 minutes.
specifically testing emergency procedures. If there's any sort of emergency called, we want to make sure that both the flight crew and the ground crew can get safely out of the capsule and away from the stack. Orion is supposed to take these crew to Mars, so we need to make sure that we have a design that supports operations from the launch pad all the way through deep space, and it's important that we keep the crew safe so that they can return home to their families.
Now, that test was for instances when the crew needs to evacuate the vehicle on the launch pad. In a case where the Orion crew encounters trouble during ascent, the vehicle comes equipped with a launch abort system, which is designed to pull the capsule away from the rocket. A full stress test of the launch abort system, called Ascent Abort 2, has now been scheduled for April of 2019 to speed up getting needed data to the engineers who are validating computer models of the performance and function of that system. Here's a bird's eye view of what that test should look like. The vehicle that will be used for that AA-2 test is here at the Johnson Space Center in Houston now for assembly and outfitting. It's part of a lean approach to minimize cost and schedule risks associated with the test. NASA has scheduled a briefing here in Houston next week to show how engineers and scientists are making NASA's deep space human exploration plans a reality. This coming Thursday, April 26th, 9 a.m. Central Time, NASA TV and NASA.gov will carry a briefing with Johnson Space Center Director Ellen Ochoa and Exploration and Orion program officials, and they will later provide local attendees with a tour of facilities and projects that are underway here in Houston. One of the priorities of research on the International Space Station is to learn what we need to know to support future deep space exploration, including sending human crews out into the solar system on Orion spacecraft one day. For years now, scientists in NASA's Human Research Program have been trying to figure out the dangers that long-duration spaceflight poses for human explorers and devise ways to protect those future astronauts. Some of that work is being done at the NASA Space Radiation Laboratory.
The NASA Space Radiation Laboratory is an outgrowth of Brookhaven National Laboratory's particle accelerator. It utilizes the heavy charged particle radiation beam from various components already existing at Brookhaven Lab to then deliver specific doses, ions, and energies of radiation to the actual NASA Space Radiation Lab itself, with the goal to determine the potential risks to human beings from exposure to radiation during space travel.
The bulk of the radiobiology data that we've collected from the NASA Space Radiation Research Laboratory has really helped us establish our space permissible exposure limits. NASA has a set of limits that helps protect the astronauts not only from the short-term effects of radiation, but also the long-term health effects. In order to establish what those limits should be, we have to understand how space radiation is different than terrestrial radiation. And the experiments at NSRL has helped us establish our permissible exposure limits in terms of protecting the crew from the risk of radiation carcinogenesis, and also setting non-cancer career limits to the brain for central nervous system effects, and also to the heart for cardiovascular disease.
The primary difference with trying to compare what type of radiation dose an astronaut would get on a mission to Mars versus what a person could expect in their day-to-day life over time is that time factor. Now, a mission to Mars, depending on when you go and how the planets are aligned and such, you're still looking at approximately a 2 to 3 year mission. And while that seems like a long time, it's very different than the amount of time that, say, a non-astronaut, just a regular person that has nothing to do with space travel gets over, say, a 70, 80-year lifespan from, say, some radon gas in the home, or from medical tests that are administered where you get a certain amount of dose from CT scans or PET scans and X-rays through the course of life. So you're delivering a certain amount of radiation dose in a more compressed period of time than you would to the person that has never been a space traveler and such. And that's one of the trickiest aspects to trying to determine radiation dose. The same amount of radiation dose delivered in a day is very different than that same dose delivered in 3 years, even though, well, it's the same dose. It's not that simple, and that has to be evaluated when you try to determine the potential risks of absorbing that kind of a dose.
If you'd like to get another look at any of the stories we featured here today, check us out on YouTube and on Facebook. The address is popping up magically there on the screen. While you're there, take a look at all the other great stuff that you'll find about NASA and America's human spaceflight program. And if you're interested in good conversation about space exploration, check out Houston, We Have a Podcast. It features folks here at NASA talking about their work and their experiences on the job. New episodes post on Fridays. And today, April 20th, my colleague Gary Jordan talks with David Smith and Paul Bookout from NASA's Marshall Space Flight Center to get the lowdown on development of the Space Launch System, most powerful new rocket since the Saturn V, the one that took us to the moon. Go to www.nasa.gov/Johnson/HWHAP, which of course is Houston, We Have a Podcast. You will find all of the episodes right there. You can also listen on iTunes, Google Play, and SoundCloud. This is Mission Control Houston.